Good morning. Welcome to our talk. We hope that you are having a good time at Ignite in Orlando. It's almost 6 a.m. in Redmond, so it's a bit early for us. My name is Diego Vega. I work as a program manager on the EF team, and I also work on .NET data access in general. And this is Andrew.
Hi, everybody. Welcome. Thanks for coming out. My name's Andrew Peters, and I'm an engineer on the EF team.
OK. The clicker works. So the focus of this presentation is going to be mostly around doing demos of the new features in EF Core 2.0. But before we do that, we wanted to, as usual in these presentations, give you a brief introduction of the products that we work on. This should be helpful because we believe that the current state of affairs in EF is a bit confusing. We actually own two different products. We call them two different flavors of EF. The classic flavor is the one that we started working on more than 10 years ago. It was designed as an object relational mapper for .NET Framework. And it's like pre-cloud, pre-mobile revolution. It was designed to work on hardware, probably a server. It uses more memory. But it has many rich capabilities in mapping that require memory. And we have this other flavor that is Entity Framework Core that is a more lightweight, extensible, and it was also designed from the beginning to be cross-platform, to run everywhere where there is a .NET implementation. We also designed EF Core to go beyond relational, so to potentially work with databases that are not relational, like a document database or key value store. They both have a lot in common. They both give you the ability to execute link queries, for instance, and they both do automatic change tracking of POCO objects, which is simple objects with simple properties. And they both offer a code-first experience. You can design your model using code, and they both offer migrations, the ability to evolve the database schema based on your objects. But the differences are more important. One question people ask very often is how to decide which one to use. And there are a few data points, like if you only care about running your application on Windows, then probably you are OK with either of these. If you care about having like more options on how to map inheritance hierarchies to the database, then EF6 currently gives you more options. It supports TPT and TPC that currently EF Core doesn't support. That is a strategy to map inheritance. It has many-to-many mapping, the ability to have two collections in two entities that point to each other without having an entity in the middle. EF Core doesn't do that yet, at least. But on the other hand, EF Core is evolving more quickly. We are investing more on it. We are creating new features. It's already doing many things that EF doesn't do, the classic version doesn't do.
Yeah, I mean, that's a really good point. We hear a lot about what's missing in EF Core, but I think it's also important for us to talk about the features we've added in EF Core which aren't in classic Entity Framework. So some good examples would be update batching, so the ability to send batches of updates to the database for performance reasons. We added that, and it's probably something we wouldn't backport to classic Entity Framework.
Yeah, unique constraints is another feature that we only support on EF Core, the ability to have a key that is not the primary key and have foreign keys on other entities, using that as the principal side.
Yeah, so the fact that we started with a brand new code base with Core really means that we can innovate a lot quicker, and we're really excited about some of the new features we're going to show you today.
Yeah. If you need to run your code in Linux, if you eventually need to run your code on other platforms that support .NET, .NET Standard or .NET Core, then EF Core is the best bet. And many of the features that today are missing are going to be added. We just need to work on it, and we need more time. So speaking of EF Core 2.0 specifically, during the development of this framework, we identified a few areas where we wanted to invest. One of them is to continue pushing so that EF Core can run everywhere where there is a .NET implementation. And we decided to adopt .NET Standard 2.0. If you have been following what's happening, .NET Standard 2.0 is this subset of .NET APIs that are implemented by many different implementations of .NET, like Mono, .NET Core, .NET Framework, Xamarin, and UWP. Given that we target .NET Standard, it means that we can compile and run everywhere, but there are a few things that we still need to polish. Like, for instance, we identified a few issues with UWP, the next version that supports .NET Standard. The APIs are there, but they don't behave exactly the same, so every time we need to do some testing and we need to fix things. But it's a good progress in that direction. We also created a bunch of new features. Some of them are about closing the gap between EF6 and EF Core. Some of them are new ideas that we came up with on how to solve some common problems. And some of those features are focused on performance. We had some analysis that we did on ASP.NET Core applications using EF Core, and we decided to implement some new features on that. And we also did some deep architecture improvements. We changed how we use dependency injection internally to resolve our own dependencies, to simplify it and to make it faster. That also led to having a change, a simplification of the provider model. And we also rewrote parts of the link implementation that we have. So let's start with the first demo. We are going to switch to the code. Compile queries is a feature that existed in the first version of Entity Framework some time ago. It was kind of removed, or it became very difficult to use when we added the DB Context API. But at the same time we were doing that, we were adding also what we call auto-compile queries. The way auto-compile queries work is basically every time we need to execute a link query, we look at the expression. We need to create a query execution plan for it. We call that compiling the query into the query execution plan. That execution plan includes some SQL that needs to be executed on the database, but it also includes some code that we need to execute in order to flow the data from the results of that SQL into the objects. And once we have this query plan, we put it in a cache so that the next time we see a similar query or the same query, we don't need to do the full computation and the full compilation again. But in order to find it, that entry in the cache, we need to compute a representation of the link expression that is comparable. And that takes some time. In our test, we found that average that takes between 3 and 5% of the time. So compile queries, or we could call it explicitly compile queries, are about saving you that 3 or 5%. Sometimes it can be significant. It depends on how much you need your application to perform. Sometimes it isn't. So can you show us how it works?
Sure. So this little program is just really benchmarking the two different ways we can compile queries in EF Core 2.0. So the standard way, as Diego mentioned, is what we call an auto-compiled query. So you just write the link query in the normal way. Underneath, we take care of compiling it and executing it and putting it in the cache. Let's run this. So this program is just going to run the query 500 times and time it. So regular was still pretty fast, 238 milliseconds, 500 executions. Now I'm going to use a little snippet. We're going to do the equivalent query, but as a compiled query. So the way this works, we have this static EF entry point class, which we're going to see a few times today. Excuse me. This is something we introduced in EF Core, and it's just a short, concise entry point API for some of the static EF APIs. And this thing you can see here takes a lambda, and it's really the same query that you wrote up here, but it's parameterized on the context instance that it should run against, and any other number of parameters that should vary each time the query runs. So what this thing returns is a delegate that allows us just to execute the query. So really what we're doing here is we're taking over caching of these compiled queries in our application, and that will allow us to avoid the sort of cache lookup EF needs to do. How do we invoke it? It's just a delegate, so we can just call it, passing it the context and any parameters. Let's run it again. Okay, so in this particular contrived demo case, we got a much better improvement. So as always with performance work, you need to measure your specific scenario in your application and understand what the gains you might achieve by making a change like this. There are a couple of disadvantages to using this. Obviously, the code to set up the query is a little more complicated, and you also need to worry about storing this compiled query somewhere.
Yeah, actually, I wanted to mention there is a pattern that we usually recommend on how to do that, or at least I like it a lot. I usually create a static field on the DB context itself, and in the initialization of that field, I just call the EF compile query method. And then I create also a method, an instance method on the DB context that invokes the delegate, passing this argument as the first argument. We are not going to just show you demos. We want to explain the features, and we want to try to give you a good sense of when to use them, because that's our goal. Actually, we want to help you take advantage of these features. And yeah, this is a feature that you don't always need, but if you really want to get like the latest bit of performance out of the hardware, you have it as a possibility. So the next demo is on DB context pooling. This is a feature that we came up with as a result of doing some analysis of profiles with ASP.NET Core applications that were using EF Core 1.0. So the general idea is that when you are using ASP.NET Core, you are likely going to have some controller classes that have dependencies. They resolve their dependencies from a dependency injection container. And in this case, the dependency of this controller is DB context. And that means that for every request that comes in, ASP.NET Core is going to create an instance of the controller, and it's going to inject a new instance of the block context resolved from DI. And that happens for every request. And that means that if you have 1 million requests, you are going to create 1 million instances of the DB context. So Andrew came up with the idea, oh, we can use the same principle that we are using in other places. We can create a pool of pre-created instances of DB context. And every time there is a new incoming request, the controller is going to get an instance from the pool, and so on, and so on. And when the requests finish being serviced, they can return those instances to the pool so that they can be reused. So let's look at the code.
Thanks, Diego. So in this demo, we're just simulating at a high level what goes on inside a web application. We have a blog class here, so this is one of our entities. Pretty simple. And we have our blogging context. Now we've instrumented the blogging context here, so it keeps track of how many instances were created. So this is useful for showing the demo. And here we have our controller. Just like on the slide, we're getting the blogging context from DI. And here we're simulating the startup. So at the moment, we're not using pooling, and we're just doing the normal startup registration of a DB context, which is the add DB context method. And then our program is just going to spin up a bunch of threads, run for 10 seconds, and see how many requests we can get through. Let's run it first without pooling. Okay, so you can see here we're doing around 5.5K requests a second, and we're creating the same number of context instances, which is what we expect, because at the moment they're registered as scoped in DI, so we get a new one for each request. Now the nice thing about pooling is that we're able to just make one change to our startup. Our controller doesn't need to change, so what add DB context pool does is replace the registration in DI for that DB context with the pool. So it sets up an indirection The rest of our application doesn't need to change. Let's run it again. Okay, great. So we can see we initially created 32 instances, and now we're able to get through close to 10K requests a second. So obviously this can have great benefits in terms of scalability, reducing GC pressure, and so forth.
Okay, so if this is so great, what is that we are not doing it by default in the DB context method?
So again, we see it as more of an advanced performance optimization. You need to measure and understand that this will help your application. There's a bunch of pitfalls with it that unless you understand, you can run into. The main one being when a context is returned to the pool, we need to know how to reset it to a pristine state so that it can be given to the next request as if it were just a new instance. And so we know how to do that for all of our internal state for the context, but if you've added your own custom state on your derived context, e.g. something like tenant ID field, for example, we don't currently have a way of resetting that stuff.
Yeah. Another point is that we also made in EF Core cheaper to create an instance of a DB context. That's part of the architecture improvements that we did. We simplified the dependencies of the DB context. We also made some of the dependencies singletons by making them stateless so that less objects need to be created every time there is a DB context. So you don't always need this, but it's a good tool to have if you really need that extra performance. So the next demo is about query filters. The way we came up with this feature was based on some feedback that we got. We actually didn't do exactly what people were asking us to do, but we did something that we believe is nice. So what people were asking us to do is to have a version of the include method that also takes a predicate. If you are not familiar with include, I think we can show it in the simple query that we have for that. Yeah. So include is a method that you can use in link queries, in our link queries, to tell us that you want additional navigation properties to be traversed and to be brought in memory together with the main entity that you are querying for. In this case, this query is looking for all the blocks, and it's also bringing the posts for those blocks. People wanted something like, OK, I want to get the blocks, and I want to get the posts for them, but only the posts from this year, or the posts written by this author, and not everything. And we said, OK, well, we could create a version of include. Include is already a relatively complicated API. If we add a where clause there, inside it's going to become more complicated. But what if we just put something in the model, in the EF model, that is more declarative to say, OK, whenever you bring the posts, apply this filter. So that's what we did.
Yeah, so in this demo, we want to enable two higher-level features using filters. Those features are multi-tenancy, so the ability for a context to target only the data for a tenant, and also soft delete, so the ability for a context to not really delete the data when you delete it in the context, but to actually set a flag in the database like an isDeleted flag. So let's look at how that's first realized in the entity classes. So we have the tenant ID, so we're controlling the multi-tenancy for the blog, and then the posts are doing the soft delete pattern.
OK, that tenant ID is a field, by the way.
Yeah, that's a field. So one of the nice things in EF Core is that we extended what we can map to in CLR classes. So we don't need a property for that. What we can do is actually just set up a logical property in the model using a string. We're going to call it tenant ID. And there's two ways this can work. Either we can have a backing field like we do here, in which case we tell EF about the backing field, so EF will just write to that field when it's querying the data. Or we could just not have the field at all, in which case EF will start to manage the value in what's called a shadow property. So that's where EF can track values for instances outside of the actual object and keep track of them in the state manager.
Cool.
Let's run this now. We haven't implemented any filters yet. So this is just going to print out all of our blogs and posts. And we can see we're getting tenant Diego and tenant Jeff and all the posts irrespective of whether they're deleted or not. So let's start with adding soft delete. It's the easier one. So this is the new API. We can say the entity type post has a query filter, and by default, we don't want to bring back anything that's deleted. So what we've done here is specified a link predicate expression, but attached it to the model itself. And the advantage of this is that we can apply the filter whenever we see a query for posts. So this is nice because you don't have to remember to apply it to all of your queries. And it's also nice because for any other queries that we generate, such as with include, as Diego was talking about, we will automatically apply the filters. You can run that. Okay, great. So now we're only getting the posts that aren't deleted. Now we can set up the multi-tenancy with another filter. So here we use the same API. For entity blog, it has this filter. Now this is how we refer to this logical tenant ID property because we don't have a CLR property that we can actually use inside this expression. So again, we're using the EF entry point class. It has the property method, which is the way we can refer to these logical properties in a query.
That is also doing equals to a underscore tenant ID field on the context, right? So
that's right.
How does that work?
Yeah, so each time we new up the context, we're going to pass in which tenant this context instance is for. Now, one interesting thing about this is that on model creating, when it initializes, will only run once. So we're going to create the filter once, but we don't want to stamp in the value of tenant ID at the time on model creating is running because we want it to vary. So we recognize this as a specific valuable scenario. So what we do is we look for fields and member accesses on the context instance in your filter, and we pull those out to parameters so that each time the query runs, we will get the right value from the currently executing context. Okay, great. So here we've got the logging enabled as well, so we can see there's the parameter for the current tenant, and we're only getting back the Diegos here.
Okay, cool. So that solves the query part of multi-tenancy and soft deletes. How do we solve the save changes part of it?
Yeah, so we don't have great sort of automatic support for this yet, but we've been thinking about it. So what we're doing at the moment is we're just overriding save changes, which you can always do. When you do that, you can look inside the state manager and see which changes are pending. So here we can see all of the entities that are going to be added, and we can just set the value of the tenant, the current tenant. So on insert, we're setting the value. And then we can also look for all of the entries that are deleted, and we can set as deleted.
Yep.
So we're just kind of hijacking save changes so that we can apply these changes.
Yeah, we are thinking that we can probably have a version of default value in the model that takes a lambda that refers to the current tenant ID, for instance,
yep,
as a way to do this. Okay, so the next demo is also about something that we got feedback from people. They wanted complex types. That is a very common feature in EF6, but we decided to do something else. So complex types, I think we can show the entities here that
yep.
This is a canonical example of a complex type. The address is a type that doesn't have a key per se, and you can use it to just group properties that conceptually belong together because they are about an address. And customer has a couple of addresses, address properties, and they are considered structurally part of the same customer. So one of the default expectations, especially if you are an EF6 user, is that those are going to be stored in the same table. We look at this and we say, okay, yeah, complex types are great, but can we build that feature in a way that is more composable? Can we create new features that support this scenario, but maybe are useful in other ways? And that's what we did. We created two orthogonal features that when you combine them together, they behave like complex types, but they're actually a superset of what complex types were in EF6. The first feature is called onTypes. The concept of an onType is there is an entity that has a strong dependency relationship with an owner entity. And that entity actually happens, at least from the perspective of the EF implementation, to have a key, to have its own ID. But that ID is kind of borrowed from the owner. And that identity of the owner also is combined with the navigation property that points to the onType. So for instance, in this case, address is going to, each address in the change tracker, when we are tracking it, is going to have the customer ID and the, in this case, the work address navigation property as its identity. So we can have one object that has that identity, and a different one that is going to have the same customer ID, but the physical address property as the key. So let's take a look at how it works.
Okay, so in this demo, we're just going to recreate the database every time so we can observe any schema changes that happen as we make configuration changes. And then we're just inserting the data. So we're adding a customer and setting the work address and physical address. So let's run it now. We haven't set up any own types yet. So this is what we expect. EF is complaining that the address requires a primary key to be defined. This is kind of the standard error we get. And that's because by default, without configuration, EF is trying to bring these in as entities. So by default, when we see navigation properties like this, we try and bring in the target as an entity type. So we just need to tell EF that we want these to be owned. So this is some new API that we have in 2.0, which is owns one. And we're saying the customer entity owns one work address and owns one physical address. Okay, great. So we got our database created. Here we can see the create table that we genned out. And we've embedded all of the columns for both physical and work address into the same table using the table splitting convention. So there's two things going on here. We're setting up the ownership in the core model, but then in the relational side, when it's going to actually generate the database, it's invoking another convention which says we want the own types in relational to be embedded in the parent table.
Yep. The first feature I mentioned was on types. The second one is table splitting. Table splitting works with any one-to-one relationship. You can configure it to use the same row to store two entities that are related by a one-to-one. We just happen to use it by convention for own types so that you get the complex type feature, basically.
Yeah, and you can see here we're using a similar convention to EF6, which is to prefix the specific properties of the address with its inbound navigation name.
So one characteristic and one advantage of implementing this feature in the way we did is that being in the same table is actually optional now. We could actually redirect one of these properties to a different table.
Yeah, let's try that. So this is something we wouldn't have had before, and that's the two-table API now hangs off here. So own types actually are more powerful because they inherit a lot of the capabilities of normal entity types. Okay, great. So we split out work address into a separate table, and we set up this constraint so that they're still bound together.
Yeah. Also, one thing to notice here is that because it's an own type, the work address is still an own type, we are going to implicitly include that entity. So own types they have implicit include. You don't need to explicitly tell us, okay, whenever you bring the customer, bring these two addresses, we will do it. And that works regardless of whether they are in the same table or if it is mapped on a different one. We'll do a join if necessary for that.
Yeah, so it's kind of the reverse of a normal navigation to an entity is by default we won't bring that in unless you include it. But for own types, we thought it's more useful to just bring those in automatically.
Yeah, and that makes me think of a different thing that we haven't implemented yet, but that we will. The idea is to have a once many API as well so that we can have collections of own types. And when we do that, we are going to have a pretty nice way to represent domain-driven design aggregates. How many of you are familiar with domain-driven design aggregates? OK, so we have a few people that are familiar with that. The idea is that when you have a domain model, you don't have like isolated entities or simple entities with relationships. You actually have groups of entities that your use cases are going to work with as a unit. Like canonical example of that is orders and order lines. You usually work with those two things together. You seldom need to address the order lines independently of the order. So order in that case would act as the aggregate root. And when we have this once many API, that's going to be a nice way to put that in the model.
Yeah, so it's worth pointing out that you can nest these things just like you could with complex types. So here, if we wanted to, we could extract out a country sub-owned type, and that would just be embedded again. Or the new feature would be it can be an entity type now, so you couldn't do that before. So you could have the country entity type and then just have a regular navigation coming out of the own type to it.
Yeah, that's something that the EF6 could not do. You could only have nested complex types, but not a navigation property pointing to an external entity from a complex type. OK, let's switch back to this computer. The next demo is about function mapping. This is a feature that we got in EF Core 2.0 thanks to the contribution of a guy called Paul Middleton. I don't know if he's in the audience. I don't know if he traveled here. But if you are here, thank you. And I actually want to congratulate you. Paul was very patient with us. He probably started just reading some of the very short, very brief write-ups we had on how we wanted the feature to work. And he started implementing it. He got a lot of feedback on how we wanted. And we are very fortunate that he was that patient because he got the feature in for 2.0. And he now continues to work on improving it after 2.0. So that is really great. And we want to see more of that.
Yeah.
OK, so let's switch to the other computer again.
OK, so we have our blogging context again. In this case, we're actually wanting to call a database function. So there are a few reasons we could want to do this. We could want to move processing to the database. Or maybe we have existing functions that we just want to be able to call. So this feature really enables that scenario. So we're setting up the database, and we're creating this function on the server, compute post count. So it just does a simple calculation for us. And then we can do this thing, which is create essentially a stub in our context, which will allow us to call that. So this is the new feature that was added. We can annotate it with DB function. So this tells EF that this is one of these DB functions that should be translated to this associated store function. Or we could also just configure it in on-model creating using a Fluent API, a corresponding Fluent API. Now, by default, we're going to use this name for the store function name when we call it. But we could change that. It's available as a parameter here. And we can pass the schema as well. So let's see how we call it. So as you would expect, we just write a link query, and then we're able just to directly reference this stub, pass it the blog ID. So that's the parameter the function is taking. And let's run it. OK, here, so we've generated just a query with a projection that calls the function, and then we return the results.
Paul is currently working on enabling instance methods as well. And we have plans to also support table value functions mapping this way. We also have a Fluent API for this, right?
Yeah, we do.
So the Fluent API has more capabilities. It can give you like more fine-grained control of how to map things and even map a method to some arbitrary expression if you know how to build the expression. So we have that. And we also have another feature that is better when you have built-in functions. So That is great for custom functions that you want to map in your database. But we also have this need to have functions that are part of the EF core or functions that are available to every relational provider, or even provider-specific functions that you want. I mean, if you are the Postgres provider writer, like Shay would be, and you want to have something, special functionality that is only available to Postgres, and you want that to be very easy to invoke from link queries. So we have this other pattern for that. We created this EF static entry point, and we have a functions property on it, and you can write extension methods for that functions property.
Yeah, so in comparison to what we just saw with the DB functions, these are more targeted towards providers. Providers can attach their own provider-specific functions to this using extension methods. Kind of a common extensibility pattern we have in EF Core is that you can just add capabilities with extension methods in well-known places on APIs. So we have this functions here that you can hang off. Now a provider could hang their methods off here. We've actually created one in Core because it's so useful. It's the like function. And what this will do is obviously in relational, we want it to translate down to the relational like operator. But it has the other advantage is that we have a kind of an implicit contract for these kind of functions, and that's that the provider or the implementer should provide an in-memory implementation. So I can either run it on the server or I can run it on the client, and I'm going to show why that's useful. So we have the search service. Here we've factored out some functionality into a service. Let's have a look at it. That's the search blogs method. It takes a term, and then it just runs this EF query underneath. Let's run it. Okay, so we were searching for cat, and we found these two blogs. But let's say I want to unit test this. EF Core has this really useful testing feature, which is called the in-memory provider. You can enable it by calling use in-memory database. So what this means is that you can test your application logic that uses EF without having to hit the relational database. So this implements all of the contract of EF, but in memory. So I've got my test here. I say I want to use the in-memory database. I create my context. I add some test data. And then I create my service, and I call search blogs. Now, remember, this search blogs is using what would normally translate to a like on the server. So we can run that. And we see that should pass. So this actually ran in memory and flipped over to our in-memory like implementation.
Okay. So the next feature we are going to talk about is basically taking advantage of something that the language team did. They added this nice string interpolation feature in C#6. And some of us in the team actually like using this feature a lot. And we imagine that it's a very natural thing for people to try to use as well in their programs. And unfortunately, if you're not careful with this feature, you can put yourself in risk of having a SQL injection attack. So we wanted to make it a little bit safer. So let's look at how it works.
Okay, so we have this small program where I can enter a search term. So this is user input. And then I'm using the blogging context. And I'm running from SQL. So from SQL is this cool API that lets us specify explicit SQL statements as part of a link query. So we fold this user-specified SQL into the overall link query. So it's quite powerful. It's a way of kind of what we call an escape hatch API, where if we're not generating the right SQL for you, you can kind of drop down and do this. But this thing obviously needs to take parameters in this case. So we have the search term. And we're using, in the traditional from SQL API, like the one we shipped in version 1, it just uses the typical .NET string format style split. So we have placeholders and then arguments. And so you can see how we can do the correct SQL parameterization here because we have the kind of arguments on the side separated out. Let's run it. Okay, so if we look at the generated SQL, we can see that the user input is correctly parameterized.
Yeah, one thing to notice there is that you gave us some SQL, but you also added some link operators on top of it. And what we are doing is we are putting the SQL that you gave us as a nested subquery, and we can do the order by on top of that. If you just give us some SQL and you don't apply any additional operators on it, we will just execute your SQL without any additions.
Yeah, so that's kind of one of the advantages of from SQL is that it's composable. So as you continue to use link after it, these things will still work. We just sort of compose over the SQL that you provided.
Yeah. Unless the thing that you gave to us is the name of a store procedure that you wanted to execute.
Yeah. Okay, so that's kind of how you do it now. Now I want to show where this can fall down. So I'm going to comment that. Bring this one in. So here, we're using C#6 string interpolation because we like it, we want to use it, but we haven't thought about the potential SQL injection vulnerability here. So we're just, at this point, we're concatenating strings, which is always a bad thing to do with SQL. Let's run it. Okay, luckily in this case, it crashes because cat is not properly quoted. So the SQL itself that we're generating is now malformed. But obviously this is a classic SQL injection attack vector, and a malicious user could craft something that would slot into there and cause something bad to happen. So this pattern still doesn't work, but what we did do is we were able to make half of it work, in that you can do this pattern. So this is the same thing with the interpolated string, but it's been inlined in this case. It's not in a variable anymore. So what this means is that we can add an overloader from SQL that uses a special compiler type called formatable string. And what happens is when the compiler sees this now, it will split the arguments back out from the format string so that we can still do the correct parameterization. Let's just run that to make sure. Okay, great. So we're seeing the same thing we saw in the first case.
Okay, what if I want to use a variable? How do I do that correctly and safely?
Yeah, so there's a little trick you can do here to tell the compiler explicitly that you want to use that formatable string type. So now I do that, the compiler is going to not default to just building a string, it's going to turn it into this formatable string, and that's the one that we need for it to be split out.
Okay.
There we go.
Okay. So I saw this in a phone presentation the other day, and I wanted to have a slide like this. I don't know if it worked very well in the presentation, but I hope it works here. We wanted to give you a glimpse on the next version of EF that we are working on. We are not going to just talk about the roadmap. We are going to actually do some demos, hopefully. They will work, even if it is very early. So we have a bunch of features that we are working on. This list is very long, and we are not committed to actually finish all these features. We are committed to finish some of them, and we are committed to starting some of them. But it's a very interesting list. It's based on customer feedback. You are going to see probably if you are like a hardcore EF user that your favorite feature is probably still missing from this list. So we wanted to have a conversation about that with you. We are more often getting this kind of feedback. It's like, my favorite feature, X, is still not supported in EF Core, and I cannot adopt EF Core. And how can you guys even release this, be one of these products without having that feature? And we understand that many features are important. The thing is that if we get feature X in a release, then maybe we cannot get feature Y and Z in the same release. So we are a normal development team composed of humans still, and we are trying to get all these features in, but we cannot make everybody happy at the same time. This is how we think about what features to put in each release. First of all, we try to get a sense of how much this is going to help people, the new feature, and how many people we can help with it. We get a sense of that through the feedback that you give us on GitHub, on user voice, and in Stack Overflow and everywhere. We also look at what workarounds are available while the feature is not implemented, and we try to reason about whether those workarounds are reasonable. We do our best effort. Sometimes we make mistakes. We think that the workaround is usable, but it isn't for everybody. We also look at features, and we try to assess how much those features can help us support more scenarios in the future. It's like we try to build EF, as we explained, with on types and table splitting and global query filters. We are trying to build EF as a set of composable features that can be used together to target different scenarios instead of coming up with ad hoc solutions for very specific needs. So we try to value features in that way. We also look at the synergy between the features that we are building, and sometimes we make strategic investments, like for having EF work better on Azure, or having EF work better on .NET Core, or in Visual Studio, or with some popular package like Automapper, or anything that customers are using together with EF Core. We also obviously have a budget. We have n number of people available to work on a feature at the given time. And the good thing is that we are open source, so that some people that are working on features are not necessarily part of the team. And I just wanted to emphasize that. I think that if you want a feature really, really hard, and it's one of those features that are not like super complex things to do, think very hard about giving us send us a message and work with us on creating a pull request and add the feature. We are super happy to work with people on that. So the first demo that we are going to do is one of the things that we are working on, and we call it view types. Right now, this is like a code name, a working name for it. We are not sure that that's going to be the final name for it. But this idea of view types is the ability to map in the model a type that doesn't have a key at all. That can be useful if you are trying to map views that don't have a key on the database, but it can also be useful if you have a legacy database that have tables without keys. And because there is no key, basically we don't have the ability to update those tables, but at least we can execute queries against them, and we can materialize objects, show you the data. So let's look at the demo.
OK, thanks. So this demo, we have a pretty standard, like a shopping cart context. So we have an orders context. Let's have a look at the entities. We have our orders context. We have order, and it has product and customer. So these are all entity types. Now, we want to show a UI, which is like an order summary page. And we have a database view that we want to use to do that. So here, when we're setting up the database, we're just inserting some test data. Diego and Andrew are the customers, and we have empanadas and meat pies for the products, and then the amount of each we've ordered. Now, we've created our view here as well. So this is just part of our database setup. We're creating this order summary view, and we'd like to be able to just leverage that from EF code.
So before you do that, can you probably increase the amount of empanadas I'm ordering?
Sure. How many is good for you?
20?
50?
No, 20 is OK.
20.
I'm on a diet, so I cannot do
21.
50. OK, thank you.
OK, so we need to go through a few steps here. First one, create our C# class that we want to use. So this is nice because we're just creating another POCO. Now note, it doesn't have the ID. The ID is being projected out of this view. Could be useful for some other scenario, but we don't need it here. We're not going to use it. So we're just going to project out amount, product name, and customer name. And then we have two string methods, so we can just see, when we run the demo, what the order view looks like. Now we need to tell EF about the view. We can do that in on-model creating. So here's the new API. This is currently called view, but this name could change, as Diego was saying. Towards the end of a release, we all get in a room and argue vehemently about what new things are called. But right now, because I wrote this, I get to call it what I want.
So an idea, why don't you send us your proposal for a name for this? And if we pick yours, we are going to send you the empanadas.
The 21 or the 12?
We'll try to do 21.
50, okay.
50? Okay.
So we set up the view. We tell if about the view. And here, we're calling toTable. So this is another example of reusing a lot of our existing pipeline. Underneath, the views are really implemented using a lot of the current code we have. And so we're using the toTable API here just to target the view at the database view. Now, this could be confusing because it says table, but toTable in EF has always meant this is the database object that this thing maps to. It never has to be a table. We don't check that it's a table and throw if it's not a table.
Yeah, we're thinking about having just a synonym API for this that doesn't imply that it has to be a table to make it less confusing.
Yeah. So we're going to map it to the view here. OK, now how can we get at the views? We need something like a set. So if we have db set, we should have db view. This is our view property. And here I'm just calling the underlying non-set method, the view method that I've added, because we don't do automatic initialization of these things yet. So normally EF does a thing called set initialization, which is, oh, I see you've got your orders here. I'm just going to populate it with something. So I'm just doing that. And then finally, we can query it. So the same code we would write for entity types. OK, got the logging on here again. We can see we create the view. And then we just generate a normal query. So we're reusing most of the same pipeline, but we've just introduced this kind of new modeling concept for more flexibility. Now, the nice thing about this is that because we're reusing this stuff, views could have inheritance. We're not going to stop views from using inheritance. We're not going to stop views from having outbound nav props, for example. So they get to take advantage of like all of the full mapping capabilities that you get for entity types, but we just relax the key requirement because for views, you don't really need it.
Yeah. Also, for some background, I think that the way we arrived to creating this feature was based on some common feedback that we get that people want to use from SQL with a type that is not mapped. They just want to materialize some ad hoc object that based on a projection, and we believe that this is actually a stepping stone to support that. Okay. So the next feature we're going to show for 2.1 is data seeding. This is also something interesting that we decided to come up with a different implementation, a different design from what we had in EF6. So in EF6, we had this migration configuration class that could have a seed method, and we would execute that method every time there is a migration being applied to the database. But that method had a few limitations, like you didn't know ever if a row was already in the database at the time you were applying that method or if it was going to be inserted. So we had to come up with an extension method that wasn't very efficient, add or update. We also had to maintain that method always to reflect the latest version of the data and the latest version of the types. So we come up with something different. And actually this, I also want to congratulate the person that worked on this. We had an intern called Martin Cole. He worked with us for like 3 months or something like that, and he implemented this feature and a different one also. He ported the system data ODBC to .NET Core. It was great to have him, and he did most of the work, but now we are like polishing after he left the team to get it in 2.1.
OK, so we have our normal blogging context here, and this time we've enabled theming. So if we go down and have a look at the entities, so we can see your blog has a theme. Now we'd like to seed the database with a bunch of these themes. So we have this new Fluent API and on-model creating seed data. It's nice. What I can do is just pass in theme objects. So what I'm really doing here, and this is for the first time in EF, is that you can actually associate some data into your model. And this has a number of advantages that we'll see in a minute. So we haven't created the database yet. We're going to use migrations in this demo, just so we can see what's going on. Spinning. Okay. Okay, cool. So we genned our first migration. We scaffolded it out. You can see it's doing the create table for the themes. It's doing the create table for the blogs. This is all normal stuff. And then down here, we should see, okay, we're inserting our seed data. So what we did was we obviously updated the migrations diff engine to understand this new kind of metadata that we've added into the model, which is the seed data.
Yeah, this is something that we actually plan to improve a little bit. So this is just data. This is not bound to the actual theme type. It needs to be just data because otherwise all migrations would stop compiling whenever you change the shape of the theme type. But we want to have just a single operation, insert data, mention the names of the columns, and then all the rows together in the same call instead of having split. But this is very early. We haven't finished the feature. We are going to have that probably for RTN. OK, so let's take a look at what the SQL would be. I'm going to script it out. OK, so we gen the SQL from the migration. And down here, we have a bunch of pretty ugly SQL right now that does the actual inserts. So we're doing things like turning identity insert on because the theme actually has an identity column. And we expect to improve this a lot. This is kind of early days. Yeah, when we create the single operation with all the rows that we need to insert, we can probably automatically simplify this to be just a single batch of SQL. We need to do the set identity insert on and off in SQL Server because you ask us to have a specific key, 1, 2, and 3 on these themes. And the column on the database happens to be an identity. There is no other way to get there. Those values. OK, so I'm going to apply this now. Update. So this is actually going to run the SQL now and create the new database. OK, great. Let's go and have a look. Seed data. Where did I drop it? Let's refresh. Data seeding. OK, I must have broke something. Let's refresh again. Oh. Invalid URL filter. Well, OK, so SQL management is broken. Can you try executing the application to see what happens? Oh, yeah, let's just run it. Good point. So we just have a for each loop on the main method that is going to show. Yeah, so we're printing it out, and we've added it to the database. But the key point now is that we want to actually change it. So this is another advantage of us having it kind of integrated into the model as a first-class concept. So let's change this. I like Alice blue. OK, great. So we decided we kind of wanted to change this theme. Now we can add a new migration, Alice. OK, and we get the one operation we expect, which is just the data update for the seed data. So this is nice because now the data is versioned like the schema. We can move down and up to different versions, and the seed data will follow along with what we expect. Yeah, you'll notice also the down method sets the value to the original value, so you can apply the migration in reverse, I guess, and go back to where the database was before. Yeah. This is something that we are thinking more about how to leverage, how to take advantage of it. We think that one possibility is that we are going to probably just assume that the seed data is in the database. So whenever you query for those entities, probably we don't need, there is at least a gesture that you can do to tell us, don't even bother going to the database to query this data. This is reference data that I can assume is immutable. It is what the model says. So don't run queries against those tables. Just give me the data and do any fix-up in memory with it. Assume that it's there for every instance of the DB context.
Right.
OK. So we are, I have this slide repeated on the features that we are doing for 2.1. Many of these features are based on customer feedback. People really want us, for instance, to translate group by on SQL, and we actually have that almost in. We have a pull request, a code review out for that. Smith.
Is Smith here? There he is.
Hey, there you are.
So Smith did the group by work that's going in.
Yep. We can find, you can find Smith and us in the booth later today and talk about that if you want. Well, the data seeing is in. We are polishing the work that we did on that. View types is almost in.
Yep.
We are still working on some features related to that. We have include for the right types already in. So if you try the nightly bills or the daily bills, whatever you want to call them, it's in. We have system transaction support in EF Core 2.0 as well. That's in. And we also have the sample Oracle provider. That's something that Andrew has been working on recently. It's a sample provider, which means that it's not code that we are going to recommend customers to use in production, but it's something that we wanted to have for two reasons. One is to help any provider writer that needs to implement Oracle support, give them the starting point, including Oracle. They are working on an AD.NET provider at this time for .NET Core and for .NET Standard, so this is going to give them a head start on implementing the EF layer on top of it. And the other reason we wanted to do this provider is to prove that it can be done and to make sure that we have the right APIs on the provider model and that we are not missing any extensibility points that can make that provider easier to write. We want to triangulate basically what needs to be added.
And how many folks here need Oracle? Just curious. Use Oracle. Okay. Okay, decent amount. Thanks.
Okay. So another thing that we are working that is a strategic investment for us is a Cosmos DB provider. We want to do that because we want to support Cosmos DB, but also because we want to experiment with document databases. The current plan of record for that is that we are going to target the document DB API in Cosmos DB. So it's going to be our first document database provider for EF Core. We are also going to start in a bunch of features that are important, like type conversions, the ability to have a property that in order to materialize that property, we need to execute some code to convert it from a different type, from the value that is stored in the column to the value in the property, and vice versa. When we go back, we need to do the inverse transformation for that.
Those Oracle users are probably familiar with that problem.
Yeah, like for Boolean.
Yeah.
OK. There are many, many things in the list. If you want to discuss any of these features or any feature that is missing, we can do it at the booth later, or we can probably have some conversation here still. These are some resources from this talk. Everybody always asks for the demos. The demos are in a GitHub repository under Andrew's account. Our project page on GitHub is the right place for us to receive all the bugs that you find, and if you want to have any discussion about sending us a pull request with some new feature, that's the right place to go. Our documentation page is inside the Microsoft Docs website. We are working on improving that. Feel free to give us feedback on that too and to send us pull requests. There is an edit button on the documentation. You can, if you find a typo, or if you find like a section missing or some explanation that is not super clear, feel free to give us something better. And these are our Twitter accounts. We usually blog on the .NET blog, so if you need to see our announcements, it's there. It's usually something that we do in the blog. Please evaluate our session. Remember to do this. It's going to give us the opportunity to improve as presenters, so we really appreciate if you give us that feedback. And do you have any questions? There are microphones in the room that you can walk to, or we can try to repeat your question otherwise. Sure.
Are there any performance metrics difference between EF2 and EF6 in the core and the 6.0?
Okay, so the question is whether there are performance metrics differences between EF6 and EF Core. Do you want to answer?
Sure, yeah, so we really focused on perf for EF Core in general. So in general, most operations, if not all, are faster in core. Sorry?
Why?
Why? Because of the way that we architected core versus the way that the other thing was architected. So it was really one of our performance is a feature type deals. So we were measuring early and we were really oriented towards that. It's also one reason why we don't necessarily need to or want to implement really complicated mapping features, because they can obviously increase the complexity of the internal code a lot. So we were more leaning towards like a micro-ORM style, but still having a lot of useful features. Some of our, for example, query tests, we're on par with Dapper just for raw materialization speed, which is pretty good for us because we do so much more than they do as well. Sure.
Question?
Is it working?
Yeah, you had mentioned the Oracle support, the sample code for EF Core. Oracle's actually critical for my company, and the lack of Oracle support is causing a lot of pressure not to use this technology, but to use others. So I know Oracle's working on hopefully a Q1 delivery of their driver. Are you expecting them to write the EF 2.x code to coordinate with their client driver?
Yeah, we really expect them to write the sort of production quality EF driver. Now, having said that, we built the sample and it's passing 95% of our functional tests, but we don't really have the specific expertise to take that to the next level where we can really confidently say, we're mapping all of these data types correctly, everything is working as it should for Oracle.
Are you using their beta driver that works with .NET Core?
So we built the sample on their managed desktop provider.
Oh.
So their existing one, because we support desktop as well, so we just use that. EF Core runs equally well on Net Core or desktop.
Yeah, so the idea is that when they have a beta available to us or to anybody, we are going to switch to that. So we are going to start running our tests on .NET Core as well.
Do you have an anticipated date you might get a beta?
We have the same answer that they have published, is that they are expecting something by the end of the year, probably a preview. And we talked to them the other day, actually, and they said that they are probably going to update this intent. What is the name of the document?
Not sure.
Statement of intent
to
support .NET Core very soon.
Yeah.
All right, thank you very much.
Thank
No
you.
worries.
Can you guys put the links back up on the screen for us?
Yep. No problem.
Thanks, everyone.
Thank you.